So,
Yeah,
okay.
I got it.
So a couple of the
But
key
you can
things.
still do that though. Yeah.
Screen capture?
Sure, why not?
Okay.
That'll work.
Is it a kite?
Okay. CLIHA. That's going to tell you what machine you're on. You can see here we're on the active machine. So
Okay.
whenever you're tracing, if you take a trace and you're getting no packets and you're like, this doesn't seem right, you're probably on the standby machine.
Okay, cool. So high availability.
That's right. It'll also show you which one, the top guy down here for the database status will always be the one that you're on. And then the bottom one's always the peer, so you can see the database setup. Also, you have monitor resources. So in here, we should probably also be monitoring things like the physical interface. That way, if a link goes down, we fail over from one to the next. And then you can also put other kinds of processes in place that if you want to monitor, if they go down, you'd fail over as well too. If any of these go down, normally you'll see that this goes into an impaired state and it
Okay.
fails over to the other guy.
Gotcha.
This is like a health, like a show health.
That's
Exactly.
That's a question.
I'm trying to think of.
Let's say if you've got a-
all stats.
Yep. So all stat is another command. What that's going to do is that's going to show you the version. This is going to show you a ton of information. Now each one of these, there's smaller commands that don't print as much stuff, but if you remember anything, remember all stat because that'll tell you, all the things. So here's the version number that I'm on, 81T00D8. I can see all the processes that are associated with the iServer and they're running. What's important here is I can also see the memory usage that's being used. So,
Okay.
there's other ways to see with doing memory as well too.
Okay.
Just for the Unix stuff. You can see the iServer uptimes. You'll also see your license information when it's going to expire. You guys will have timeless license right from the get-go. So you really won't have to worry about updating licensing and stuff. But some of our smaller customers, if we do financing for them or whatever else, you get your license, you give us a check. You get your license, you get a
Right.
check. So that's
What was the command again? I'm sorry.
all stat.
I'll start.
You'll also see how many concurrent calls are up. So here's total number of viewports that are in the license is 10,000. Number that are available, 10,000 because none are being used. All your calls will be media routed. So you'll see those as well. If you wanted to see like transcoding information, CLI DSP is all about it there. So if you do CLI DSP stats, it's kind of a lot to consume at first, but it's easier to see once there. So they actually put in every combination of codecs that are currently supported and what the transcoding would be. So
Okay.
if you wanted to know the number of sessions that are doing
Uh-huh.
711 to EVRCB, there's your line.
Okay, you can also specify that on a per realm basis, right? I would imagine, right?
No.
Yes. No, you can't?
Not on a per realm basis. You're not going to see how many transcoded calls are going on. Because what's going to happen is 711 is probably going to be on one realm, and the EVRCB would be on another realm. Right?
Okay.
Because the calls generally are coming in on one realm and going out on another realm.
Gotcha.
And then you would also be able to see.
Can
up
you
here-
see? I'm sorry. So can you see? You only see total sessions, not if it's like on for this specific endpoint.
True. Now on the endpoint, you can log in and see how many calls are going on an endpoint.
Can you verify the actual codec being used and how many sessions for that given endpoint?
That's a good point. So what you can do, so on an endpoint, let me show you what I have, and then we're probably going to may need some kind of feature enhancement or something. One more. So here I can go down and I can see total number of ongoing calls. It doesn't break them up by what codecs are being used or anything else, but just total number of calls that are there.
Okay.
If I wanted more information, and it may be in here, we need to pin some calls up to check. There's a CLI call cache, and that's going to actually give me every call that's currently up, what phone number it came from, what phone number it's going to, from what endpoint to what endpoint, and it's going to give me my media information related to what's the RMA IP that it's using and the RMA ports. And then I guess you could get even more
What is
detail.
the output of CLA call cache?
You need to pin a call up so I can show you. Why don't-
Yes, I'm gonna go get I don't know if it'll reach, but I'll go get one of our phones.
Well, I was gonna just throw some through SIP. We just finished configuring it, so we can toss it
I'm so
up.
old school. I'm way old fashioned. I need some help.
I just might need some help with what the IP is. 252.
122.
122, 100.
Yeah.
C, J, C.
Say Jacob,
Zero C?
0
Zero, zero C.
Nobody said it.
And
Comcast. Bang.
We're so
Capital C?
secure.
No, small C. Small C, 0, Comcast bang.
That's how you can hack into Comcast. Password. Clearly, it's the same for everything.
all right, so let's see if this works. 403. Probably because I sent it from 100 and I should have sent it from 101.
USC was 100.
And so UAS was 101?
Yeah.
UAC should have been 100?
Yeah.
I thought that's, and I should be sending, let's see, CLI Edge, LKUP, 10,
252, 122, 122, 101. Yeah, 100 and
100 is the UAC,
See,
right?
100
yeah,
is
that's
UAC.
UAC.
I'm just trying to see what realm it's supposed to be at. So it's on the peer realm,
why?
and peer realm should be here.
No,
So I should be sending this IP address. That's what we got the 403. Yeah, it should be sending to 5060.
cool. Oops.
And you got a 180.
180. Yeah.
All right, so here's how you troubleshoot T-Shark. So I'm just going to run T-Shark. I'm going to send the call through. I'm going to see what happens. So, this is the code map testing I was doing earlier.
Whammy.
Yeah, I was trying to prove something. I think I must have launched the UAS that's supposed to send back the wrong response code. My bad. Yeah, it's supposed to send a 475.
That's funny.
Right. That's what you get for just flying through somebody's history and trying to use one of their commands, you know. Let's just do SIP. All right, cool. That's how we got it. So now we just need to put a delay in here. Take this out. Leave them up for 180 seconds. All right, so now we got calls going through. So now if I wanted to look, I do a CLI call cache, and then I need to dump that out to a file. Now when I look at, okay, another command, lstat, shows you how many calls are up. And CLI call
Why?
cache.
It is showing used reports.
What?
Wait, it's showing 17?
Because I've got it penned up for 3 minutes at a time.
Oh, okay.
So this is the output of CLI call cache. I can see here that from endpoint SIP P02 UAC UPort 0, which is this IP address, the ANI is SIP. I can see that the DNIS is 1856663. I can see how long the call's been up. See, this is where I would have thought we might have something, but in the M line, I can see what media ports, where media is coming from, where it's going to. Doesn't look like there's any codec related information. Let me check one other place. So, OCLI, our DSPs are made by Octasic, so we have an OCLI for Octasic CLI, which actually puts you into Octasic, into a CLI so you can talk directly to the DSP card. XStat counters is the one I've used most, but this shows me what's going on with my DSPs and how much load is going on. Board. I'm just wondering if there's just something in here that can show me. I don't see anything related to specific codec information. Let me ask somebody else about that. If there's nothing, maybe we should.
No, but if at all you go to the, OCLI, you will see only specific to.
About the,
BSP.
it wouldn't be. You guys want to say, hey, this endpoint is doing how many calls by this codec?
Yeah. Do we have it in my opinion?
What's that?
What?
The transcoded.
Yes, you do. Yeah.
On a per endpoint basis.
Yeah. On a per realm basis.
Where?
Yeah, show SIP codecs, then the realm.
Oh,
Mm-hmm.
Yeah, so far, so the best we have right now is this.
So if I had wanted to, you did the call cache, actual, like, an active call, like to see the actual messaging. Like we would do like a call trace.
Yes, the T-Shark command. So T-Shark is the tracing utility. You do -I for interface, and then you say any, so that'll just include all the interfaces. Your blanket trace is going to be port 5060, right? So most everything's going to be happening over there. And if you want to write it out to a file, you can do -S-W and say file.cap, or call it, whatever you want to call it. That will start running, and you'll see calls go through. Now, let's say that the rate is really high, right? And there's 21 calls a second flying through here, and how are we getting 503s?
Okay.
Okay, so now you want to end up looking back through this call and look for a specific phone number. So our file.cap is just going to replay the whole thing. You can put filters in and say, if you bring it into your PC, you can do all the same stuff too, and you guys are probably real familiar with it, but from the command line you can do these same things. I could say SIP contains, and then the phone number. And it's going to show me anything that had that phone number inside of it. So you can do a lot of stuff from the CLI itself.
Okay.
No. Sorry, go ahead.
So what if you had an issue with, let's say, one of the logical elements within the box, its configuration? The call is killed, it's one of your elements, one of your configurations within the box, and you need to troubleshoot it. How would you go about doing that?
Without knowing what it is. Right?
Exactly.
So,
Like say your call fails, and it's the error is generated by the SPC, but you don't know what's wrong. Like
so I'm looking at the trace. The invite comes in, and I send a 503 immediately back, and I go, why am I rejecting this call? First thing I would do is I'd look at the CDR record, right? So we have CDR records that are printed for each call, and those are all in var CDRs. So the active one is CDT. That's going on right here. So if I do TC, that's an alias for just tail minus alpha for the active CDRs. And you can see there's tons of CDRs going in because there's tons of calls going on. And they're all actually failing because service unavailable, media gateway resource unavailable. So it's upset about something all of a sudden. I was not sure exactly what it was. So obviously those are hard to read in that fashion. So if you were to take a sample, this is how I would do it. I would ask the person, well, what phone number did it come from, or try to get some kind of unique information. Maybe it's a specific endpoint. So I would say cat, this CDR file for today. And now when I grep for, I could say the endpoint name, I could go SIP, let's see, what do we call it?
How about the phone number?
CP02.
Can we use
Phone
the
number would work too, because
Yeah.
that's written in there as well too.
Okay.
So 856 something,
CDI.
638.
638. Now let's say that's enough for now. Unfortunately, since all our calls are going to the same number, this isn't going to be a great example because it doesn't accurately represent what really happens. So now when I search through, I still see all the same exact same ones, right? But then I would probably put that out to a file. Okay, so now I've got my file, and I'd say you could look through it and try to find the one CDR record you're looking for. But eventually, once you narrow down what you're looking for, we have a CDR decode script. Okay, so now I can just pipe that to the out file. And now when I'm looking at my CDR records, they make a lot more sense to me. I'm able to see, hey, okay, this is where it came from. This is one. The call error was forbidden, user blocked, and I can actually decode a lot more information as to actually what's happening with the call itself.
So in the case of that, what would that lead you to look at?
It depends on the error.
Yeah, I was gonna say, do you have a guide?
Yeah, inside
Okay,
the
cool.
operations guide, there's a whole
That shows
section
how to
on
use that.
CDR errors and you know what to look for.
Okay.
403. So here's just some common things. If you see 403 come back from the SBC immediately, look for a provisioning problem. Right. 403 is going to be forbidden. That means we couldn't find the load. That's what we'll send to anybody who's trying to send something to us. So we didn't find the source endpoint
Right.
to allow it to come in. If we send a 404, that means, hey, we allowed you to come in, but I didn't have a way to route the call that you specifically wanted to
Right.
route. So I have some kind of routing issue. If you
So
see,
based on that, like for us, that would be like a local policy was missing, and that's kind of when it comes in, it says, hey, you're going here, based on whatever you're from, you're around, whatever. So what's equivalent to like a local policy?
so on us, everything gets routed to the redirect server going out based on the new source destination trunk group. We're bringing stuff in, and so the inbound carrier, the line that causes it to get routed to the redirect server is right here.
Okay.
So I would go and look to see if the new source destination trunk group is there.
New source does.
Yep. And if it is there, maybe the destination trunk group got ripped off of the redirect server. Right? Because this has to match the DTG on the redirect server itself. So that and this tie together, forcing the call from here to here.
Okay.
It's not based on policies or routes. It's basically based on the endpoint configurations.
Mm-hmm. But that, I mean, that, at least if I can see what I know to be logical today, if I can associate it to something, then it helps, and that makes sense.
Okay.
That's the next destination. So that makes sense to me.
Yeah.
Trust me, I think during the cert time and working with it, we'll spend a lot of time kind of going, especially when we run into something, why isn't this working? Alan, why isn't this working? And then I'll have to go, I'm not sure. And then as we work through it, I think it'll
Start to make
show,
sense.
yeah. We have a good one right now to even figure out, right? So we're, all of a sudden, everything was working, now calls are working again. But we failed a ton of calls, and I'm just trying to figure out what had happened. It said media gateway resource not available, so I think it's a good exercise to actually find out what happened.
Is there any debug logs? Like
There is, in var log iserver.log, there's a debug log. And there were a bunch of errors. Port available call for destination failed. Bridge. It's happening exactly at 100 calls. Oh, I know what the problem is. Okay, one thing to note too that I did not bring up earlier. So, whenever you create an endpoint inside of RSM, by default, as a warning thing, it puts the max calls at 100.
Oh, okay.
And so when we created that endpoint inside of RSM, we set the max call. It set the max calls to 100. I guarantee. As soon as I saw that 100, that's the wrong thing to search on. What was it? There was a UAS.
It's there. Try searching on 101 IP address.
Yeah, this, and there it is. See, max calls equals 100. Ongoing calls is 100. So if we just change this, zero means unlimited. Now, yeah, we're going way north of there. The way I saw that was just when I saw that we were limited exactly at 100, that kind of made sense. But otherwise, you would actually, let's see, inside the RSM, this is a good time to use RSM. Because whenever you exceed, I think, the max call duration, it sets an alarm in the RSM. So looking at the RSM page, what was it,
173.
173, or 255. Yes, right there. So that triggered this red alarm that a CAC failure has occurred on this endpoint on SIP-P UAS2 because we exceeded the max number of calls, so it immediately kicked up a flag to let us know that there was an issue. So there's another good place to look at inside of the RSM. When something goes wrong inside the SBC, it normally tells RSM, and then the RSM will display it on the alarms page to let you know, hey, you might have a problem.
Can you, in the RSM, can you reboot?
The SBCs, you can fail them over, so from the devices page.
You just looking at me like, why would you want to do that? I like rebooting SBCs. They solve all problems.
I would believe that. I'm not going to argue with you. I'm not saying I haven't seen a reboot fix a problem and left my head scratching before, but
But that's where you would do it, that little...
that'll fail them over.
Fail
That
them.
swacks them. You know.
That's good enough.
But if you just SSHN, you can just type reboot,
Reboot, no.
and you're good.
Does it give you like the warning, are you sure, or it just lets you do it?
It's Unix.
Nice.
That says if you typed reboot, you should know that you typed reboot.
That you type reboot.
Wow.
So, I mean, in theory, like, let's just say if there was a reboot, since there's a pair, we're expecting that we should not have any, like, retransmissions.
Retransmissions?
Like, any call failures,
Okay.
any call failures.
Okay, no. From a reboot, you're not going to have any call failures. So this is actually what happens with a failover. We've worked on the failover stuff for a while and got it really good. So I've got 2 SBCs and 2 media cards that are connected. So every time a call comes through, I'm sending it out. I'm opening up on this IP import what we call a redirect. And what that is basically saying, hey, if it comes from A going to B, it needs to go out C and go to D, right? And so I've built this. I'm also going to come down to the peer, and I'm going to build that exact same redirect here. When we fail over, all we do is we send out, so you've got a router on this side and a router on this side. So we send out gratuitous ARPs. We'd send out a gratuitous ARP from the standby that says, hey, this IP is now at this MAC address. Even though we've failed over, if I run all stopped or reboot here, it's still forwarding media through here. This guy sends out a gratuitous ARP. If he still receives the media packet, he's still going to forward it out. So this guy, let's say that the router receives the GARP and decides not to actually implement that for a half a second, which would be like a lifetime in the whole thing, right? As long as it's still forwarding to this MAC address, we're still forwarding out going here. As soon as he decides to honor that and he comes down to this one, then we'll forward it out. So we actually sleep everything for several seconds after the failover and still forward the media. So that as soon as we, sequence number 571 comes in here, 572, the router decides it's going to go down here, it's going to get forwarded out as well. Now, if let's say a gremlin walks in and chews through the power cables on the active, right? This guy polls, he's polling him every 2 seconds. No, I'm sorry, every second. And if he doesn't get a response, after he gets 2 failures, he'll go, okay, active is no longer responding to me, I need to go active. So in that case, if he chewed through the power cables and the thing goes down, it could take up to 2 seconds for this to actually get him to bed. Actually, it's from 2 to 2.9, right? Because if, let's say that it happens at time value 0, and the last poll came at negative 0.9, the next poll will come till 0.9, and then 1.9, and then it times out at 2.9. So it's, I mean, I'm just being, I know it's not, the numbers aren't great, but this is where the best, you know, there could be a very short amount of time that the audio is down, but as soon as it fails over and the GRPs go out, boom, everybody's right back online. And also, if you have failures or whatever else, if there's call failures, you have any questions, take the T-shirt trace, email it to me, or anyone in this room. Any of these guys can help. And or Shrikant, you're going to learn a team of people, right, that are here to support you. It's not, you're not going to have just like one person assigned to it. But always send it out, ask any questions, feel free, and we'll take a look and try to get to the bottom of it.
So I think during the first week, beyond doing the upgrade, that's when we try to do the most impacting type of test, like failover, load.
Sure.
Because if it's going to break, it normally breaks with that stuff, not with us calling from Pier to Cedar Point. That call doesn't break.
Right.
So that's the stuff that we'll do first. So you guys.
No, that's
will
the
be on
best.
it.
Let's try to hit the worst, the hardest tests that you think that are going to make it fail the quickest.
And that's life lessons learned from.
Right, but that also gives us more time to get anything fixed. If let's say if we hammer something out, it's better to hammer it out on the first day of cert than the last day of cert. You know.
Agree.
It's.
Yep. So that okay.
Okay.
You're in charge
yeah,
while I'm going.
Okay, gotcha.
You have to go to my meeting.
And of course, I've got more questions for you. So you can actually ping devices, right?
Yes.
All 3 wise. Can you
Yeah.
perform trace routes, layer 3 wise as well?
Yes.
Okay. Could we? Can any? I mean, we.
Sure.
I know you've got the
No, let me-
SIP server set up, but
No, let me show
one
you.
hop.
Sure. So let's say we're going
I
to.
want to see how that
These are great.
works.
This is great. I mean, and Andy's got a lot of experience, especially with doing integrations and deployments where he's found all kinds of issues. So if you have ideas, tell him, speak up and say. So generally what we do is, what we want to make sure we have connectivity to is our VNets.
Okay,
right?
cool.
Our
And
default
that's-
gateways that
gotcha.
are there.
Mm-hmm.
All right, let me explain
Because
something
I was going
before
to
I
ask
show
you,
you
how
this
would you
and tell
verify
this,
the
because I don't want
VLANs
it
that
to
they're
be-
active, and how would you?
Okay, so what would be really cool is if the SBC actually just plumbed all these signaling addresses directly to ifconfig on the interfaces, right?
Mm-hmm.
The problem is that there's a feature that a lot of people like, we call overlapping IP addresses. So what it means is if I have VNet 100 and VNet 101 and VNet 102, I might want to plumb the exact same IP address into all these different VLANs, right, for subscriber-based information, or if I have like a whole bunch of peers that go over VPNs and stuff. So we allow this to work. The only way to make it work, though, is we have to map, we have what we call internal IPs and then external IPs. The external IPs are the ones that you know. Those are the ones that you've provisioned in your realms. The internal IPs are always going to be these 169 addresses.
Okay, gotcha.
So at the very last minute, as everything goes out of the kernel actually does the natting for
Okay,
us
cool.
from the internal IP to the external
Does it
IP.
perform PAD as well?
Well, I don't think we're going to do any port translations on it. I think it's going to map one-to-one for the ports. I think it's just the IPs that are being netted. So what we have to do whenever we use an application like Ping or something else that allows us to source from another IP address, it doesn't know about this stuff happening. We have to ping from the internal IP. So to get your list of internal IPs that are mapping to external IPs, there's a command called OLIP map. in the CLI. So CLI, OLIP map, I'm going to say for my RSAs, show me all my RSAs and my mappies. So here I can see that my external IP 6597.220 actually maps internally to 169.254.64.4. I can also see my realm name and the VNet name that it's associated with. So if I suspected there was a problem on my, say on my peer Comcast realm, I would try to ping the gateway associated with peer, which is that one. So I would do ping -i, because I want to source it from this interface. I'm going to select the internal IP address of the realm, and then I'm going to try to ping the gateway address. Right? Because otherwise I'm going to use my default route, which is going out my management interface, which I may or may not be able to have the connectivity. So now I'm pinging directly from that
interface.
realm.
Okay.
So that's how you do it. And you can go off, I mean, it doesn't have to be on the same subnet. You can route as far out as you want, right? So if I wanted to go to 4221, I don't know if I can, but I can. So I can find, hey, this signaling interface can reach the peer of whoever it is. So any endpoint that's on that realm that allows ICMP should be able to do that.
Can you scroll up just a little bit? Right there. Thank you.
So those are the base connectivity tests that are normally used from the signaling point of view.
Okay.
Okay, thanks.
Let's see. From the media interface, by default, the media interfaces do not allow ICMP. So if I was going to try to ping, if I wanted to see my media interface, I use a stack client command to talk to the HK card, because the media card runs its own kernel. So all these commands, like when you're taking T-Sharks and everything else, you don't see the interfaces associated on the media card. There are ways to get the RTP packets and everything else, and we'll go over those. I'm sure we'll find them whenever we run into media issues and we need to take a trace or connectivity issues. So if I do stack client show IPIF, that's going to show all the IPs that are associated on my media card. So why don't I test from a media point of view, can I ping 65.97.21? So I'm trying to ping this RMA and it's not working. Because like I said, it doesn't allow you by default.
So I take it just ICMP in general is just turned off, it's disabled.
By default it is on the media card. Honestly, I don't know why they did on the media card and not on the signaling. I guess they just wanted people to be able to reach the signaling. And we can turn it all off, right? We can turn it off and you can also turn it back on.
Okay.
But the command to enable it is stack client enable ICMP. So as soon as I enable it, now I'm pinging my RMAs.
Okay, cool.
So if you have someone who's saying, hey, I can get calls up but never can get media, you can enable ICMP for a few seconds and say, hey, well, try to ping the media, see if you can at least reach the media addresses or anything else. Also, with media streams, Stack Client digs in. You can go. So you know how I talked about what a redirect is. So you can do show redirect, and that's going to show you all the redirect information. And what this is in that drawing that I had up there from A to B, from C to D, this is only showing, this shows, let's talk about this chart real quick. Sorry I keep jumping back to the light, but this is just how this is why they won't let me train, because I don't know where I'm going. So from the SBC, if you have a media card, and your phone here, this is A, he's sending traffic into B. From C, we're going to go to D. Up there on that chart, you're going to see 3 IP addresses with ports. And the first one is B, the second one is C, and the third one is D. So what I'm saying is anything that comes into 10, 255, 173, 135, which is one of our addresses, on this port is going to leave this IP address, 65.97.221, on that port, headed to 10, 252, 122, 100, 6000.
Nice.
Because what's happening is SIP is handing back to us the exact same port to use to send media to for the same one. The reason you don't see A on there is because initially when we did our design, we never took into consideration A, right? Obviously that's a security hole because then you sit there and you don't have, anyone could sit in traffic here to this IP port, right? So this bad guy here can send traffic in and we're just gonna redirect it over to that guy, so that's not good. So then we came up with gave us another opportunity to create a new feature, which is called Rogue RTP Detect. So now we take into consideration whatever A is. It's just not listed on that command. So that's one redirect, and so for every call, you're going to have 2 redirects, right? As that gets my voice from him to him, now there'll be another redirect where he becomes A, this becomes B, this is C, and this is D. And the media comes from this guy into here, and then out here to here, right? So there's always going to be 2 redirects for a call. Voice path in one direction, voice path in another. Now, with my redirect, I can also do show redirect stats. Maybe stat. These are my packet counts. Starting on the outside, if we had audio, you'd see. This is total number of bytes in. This would be total number of bytes out. This would be number of frames in. This would be number of frames out. You can't see it because there's no audio going in. But what you should always notice is that there's a 1-to-1 correlation for the most part between the RTP packets in and the RTP packets going out. If you see this, you know immediately all zeros means there's no audio going. If you run it twice, right, and you can always grep on whatever you're looking for. Like once you locate it, then you can grep on it and say, hey, show me this, and you should see it moving up all the time. Another really good thing about this is, I can take these identification numbers right here, and I can grab the RTP. I'm going too fast.
No, you're good.
No. I'm messing with him. Sorry, Alan. No, you're good.
I might be.
This was so external.
Yeah, okay.
No, you're good.
Well, what I want to do is I want to make sure you guys know what can be done. I don't expect you to necessarily retain it. It's all documented inside the operations guide, and once we have a reason to do it a couple of times, I think you'll say, oh yeah, I know I can do this, and you kind of know where to go to kind of start doing it. You can take any one of these that you want and tell stat client, give me the RTP for that call, and it'll redirect that one specific call to you so you can capture it as a PCAP, and then you can go listen to it if you need to.
Cool.
So know that that's available as well. So anytime you need to pull, if you want to pull one specific media stream or 10, whatever you want, we can do that.
Is there somewhere, because I'm writing down like quick commands, but is there like a quick command cheat sheet somewhere?
Let me see what I can find. I know I've got one somewhere that I've kind of put some cheat sheet
Oh,
notes
like, you know, like the hot, like the top, whatever. The ones that are most commonly used.
Yeah, no, that's what it would be. Do you have anything like that from Anna's? Nothing. I know I've got some that I've created. I don't think we have anything.
It doesn't have to be
slated.
Gem
Right.
validated, specific, but I mean, just from your.
You do.
Don't hold back, Andy.
The DDI document, the PowerPoint, had a whole bunch of stuff in there.
You did?
Yeah.
Okay. I'll put something together. I'm gonna.
Because if you look at my cube, like I have like all those papers posted. I think it's just easier for me when I can look at it quick and do it, as opposed to trying to remember what. I like to be able to look up at my little wall.
And say, this is what this. Yeah, absolutely.
And it just
I'll
helps.
take what I have and I'll even expand on it. I'm making it as a true deliverable action. That's why I'm emailing myself so I can flag it.
Cool.
Comcast cheat sheet. Keep me honest on it too. If I don't.
I will.
If I don't end up.
Tell Elias to go do something.
Go away, Elias. No, I like Elias. He's nice.
I've known him from before
If I can just
Gym
get
Band
that.
days.
No, for real.
Yeah, because he was with Cedar Point
Oh, okay,
before
cool.
Gym Band, before they merged or they bought him out.
This is what I've been doing. Create an appointment. This is how I remind myself to get things done nowadays. So. All right, so I'm gonna make sure that I follow up on this.